So today I want to continue talking about the distributive properties, so this is part 2. And I want to talk about a coefficient. We've already been talking about this and using this in class. The coefficient is the numerical factor of a term. We'll do an example in a minute. Okay, it's the number that comes in front of the variable. And then a constant is the term that has no variable. It's just the number. So here's the example. The example is 18x minus 2y plus 14. Alright, so right now the coefficients, again, are the, are the numbers that come before the variable. So your coefficients is 18 and negative 2. Think about that. Why is it a negative 2? Alright, you got to take the sign before the number. But then our constant, that's the number that has no variable. Our constant is just our 14, our plain old regular number. So now I want to talk about like terms. And just like what it sounds like, it's terms that have the same variable factors. They look alike. So like terms, 7x, 8x, negative 3x. The reason why they are like terms is because they all have that variable of an x, right? Nothing's different. The coefficient is different, but that's fine. But they have the same variable factors. What's not the same as those examples is 4xy. The reason why? Well, because of that variable y. That's got something extra. X and xy, totally different. They are not like terms. So tomorrow we're going to spend a lot of time combining like terms. And so there's a couple steps. First of all, you need to identify like terms. Which ones look alike? You have to take the sign before the term. That identifies it if it's positive or negative. But don't forget, if there's those ugly, nasty double signs, you've got to get rid of them. Right? Nothing we learn is going away, you guys. So double signs, you've got to get rid of them. And then just add and subtract the coefficients. Now, another thing we're going to talk about tomorrow are the diagrams of distributive property. It's nice you can actually see it. So it's similar to the area of rectangles, and if you think about area of a rectangle, it's your length times your width. So here's an example. We've got 8 is one side, and x plus 5 is our other side. So I want to draw a diagram of what this looks like. Well, my length is x plus 5. I'm just going to make up, that's x. From here, to here, that's x. And then guess what? From here to here, that part is 5. So now if you remember area is length times width. So look at my first section. I've got a length of 8 and a width of x. 8 times x is 8x. I think I interchanged what my length and what my width is. Honestly, it doesn't matter. It's one side multiplying by the other side. Alright, now the remaining side, I know that this bottom length is 5. What's this up and down length right here? Alright, you should know properties of rectangles. Opposite sides are congruent in length. So that side is also 8. So my area is 8 times 5, which is 40. So now put those two areas together. What it is 8x plus 40. Now I want you to think about something. If I did length times width, and I did the distributive property that we were doing yesterday, 8 times x is 8x, and 8 times 5 is 40. It's the same exact thing that we got doing our area diagram. Okay, it's just a way to see it. Okay, we're going to be doing a lot of combining like terms, and we'll do some diagrams as well. All right, I'll see you tomorrow.